Today is Tuesday, September 12th, and we're doing lesson 1.12. That worked out nicely, huh? Module 1, lesson 12. And the learning goal today is to be able to use what you know about place value, and you already know a lot about place value, in order to help you estimate or figure out how big the product should be. Okay, we'll talk a little bit more about what that means as we get into the lesson. But first, let's talk about the problem of the day. So this one doesn't say warm up, so we're going to start taking our notes right away, okay? Now, if the instructions tell you to find the product, the first thing you need to think in your head is, wait a second, what's a product? Where do I look for the product? Where am I supposed to find a product? What does it mean to find? Am I searching like a Where's Waldo book, like looking on here? What's a product? Sanjana? Good. A product is just the answer of a multiplication problem. So if it says find the product, it just means solve the multiplication problem. Does that make sense? Yeah. Okay. If I have 4 copies of 2 ones, how many ones do I have? 2. If I have 4 copies of 2 ones, how many ones do I have? 8 ones. Now, if you don't remember, you can think to yourself in your place value chart, right? If I had 2 ones and I'm making 4 copies, I have 8 of them altogether, right? Yeah. What if I had 4 copies of 2 tenths? What do I have then? 8 what? 8 tenths, which in standard form is 0.8, right? Yep. Now, if I have 4 copies of 2 hundredths, how many hundredths do I have? 8. So it's 8 hundredths, which is in standard form 0.08, right? As we can see, these problems over here that we just did, this group, and this group, they're all math facts, aren't they? All you need to do is look at the units. I see it's 2 tenths, so I have 3 times 2, which is 6, and then it's in the tenths place. Does that make sense? Yeah. Over here, it's 3 times 3, which is 9, but this is in the hundredths place, so it must be 9 hundredths. Let's talk about these problems. Do you know your 23 times tables? No. Do you know your 14 times tables? I don't. So how can we do these really easily? Well, if you think about, don't actually do it, but imagine making a place value chart. I would draw how many dots in which column for this number? 23. 2 dots in the tenths column and 3 dots in the hundredths. And how many copies of them am I making? 3. So I would have to draw 2 dots and then 2 dots and 2 dots. So how many dots would I have in the tenths column? 6. And I would draw 3 dots, and then 3 dots. So how many dots would I have in the hundredths column? 9. So in my tenths column I had 6, and in my hundredths column I had 9. So do you see how I could do 3 times 2 in the tenths column and 3 times 3 in the hundredths column? Yeah. So therefore, we can look at this and we can say 3 copies of 23 hundredths is 0.69, right? Okay, imagine that on your own for this problem. 2 copies of 0.14. Think about how many dots there would be in the tenths column, how many dots there would be in the hundredths column, and what would the answer be. Here we have 3 multiplication problems, 31 times 4, 3 1/10 times 4, and then 31 hundredths times 4. What do these problems have in common? What do you see that these problems have in common? Andrew?
They're the same digits.
Yeah, do you guys see how they all have a 3 and then a 1 and then a 4? And it's always in that order, 3, 1, 4, and then 3, 1, 4, and then there's a 0, but then 3, 1, 4. Do you guys see that? Yeah. They all have the same digits. Okay, now, prove to me that you learned how to make an area model, and you're going to use an area model to solve each of these 3 problems. So how many area models are we making? 3. Go ahead and do that in your notebook. Okay, so earlier we noticed that all these multiplication problems had the same digits. They all had a 3 and a 1 and then a 4. A 3 and then a 1 and a 4. A 3 and a 1 and a 4. Now I want you to take a look. What do these products have in common? 124, 12.4, 1.24. What do they have in common? Talk to your table group. Okay, I heard your discussions loud and clear. You said, oh, they all have a 1, 2, and a 4, and they're all in that order. The only thing that's different, someone said, is the decimal point. Now over here, where's the decimal point? Or what's the smallest unit in this problem? Does it ever go to the tenths or the hundredths? The smallest unit is what? Ones. What's the smallest unit in your answer? Ones, right? Over here is the ones place. What about over here? Where's the smallest unit? Tenths. What's the smallest unit in your answer? Tenths. Interesting. What's the smallest unit over here? Hundredths. And what's the smallest unit in your answer? Hundredths. So what pattern are you noticing? Go ahead and once again talk to your table group. we can think to ourselves that 5.1 times 6 is the same as making 6 copies of 5.1, right? And we know, based on our prior knowledge, if we had a table place value chart, we could do 5 here and then 1 here. Would that be 5.1? Yeah. And then we would just make 6 copies of it, right? Yeah. But instead of drawing that, let's just think to ourselves, what's the smallest unit in 5.1? The tenths, right? So 5.1 is the same. If I wanted to rewrite 5.1 only using tenths, how many tenths would I have? 51 tenths. So could we say that 5.1 times 6 is the same as 51 tenths times 6? Yes. Would that be the same as if I made 51 dots in this tenths column and then made 6 copies of it? Yeah. So we can write this in your notebook. 5.1 times 6 is the same as 51 tenths times 6. Yes? Yes. And what is 51 times 6? Well, we could do 6 times 1 is 6. And then 6 times 50 is 300. So is this the same as 306 tenths? Yeah. If I made 6 copies of 51 tenths, I will have 306 tenths. Yes? Yes. Okay, go ahead and write that in your notebook. And then the only last thing we need to do then is we need to write this 306 tenths in standard form. Remember, when you're writing something in standard form, you just write the numbers, 306, and then we want the rightmost place to be in the which place value? So where does the decimal point need to go? In between the 0 and 6. So we can say in standard form that 5.1 times 6 is the same as 30.6. Our new multiplication problem is 7.8 times 3. Is that the same thing we can think to ourselves? That's 3 copies of 7.8, right? So if you were to draw a place value chart, you would know how to make the dots, and you would make 7 copies of those dots, right? But that's a lot of dots to make. So we're going to think of it in a different way, okay? But even before we do that, let's do some estimation. Let's think in our heads, okay? We can think that 7.8 is pretty close to what whole number?
8.
So is this problem pretty close to making 3 copies of 8? Right? Because 7.8 is pretty close to 8, which is pretty close to what number? 3 times 8 is? 3 times 8 is?
24.
So the product should be pretty close to what number?
24.
24. So if we get a number like 258, would that be close? Or if we get a number like 204 thousandths, would that be close? No. So we know that we're on the right track if our answer is pretty close to 24. Why is it helpful to estimate like this before we actually solve the problem? Is that helping me find the real answer? Not really. If I wrote 24, would I get the answer right?
No.
But why then is it worth it to take the extra minute to do the estimation? Arif?
To see if your answer, because if you get say if you get 23 and with the decimal, then you know that it's more likely to be correct than if you get 26 or something.
Okay, and also does it help me know if I got 2,500? Would I know that that's right? No. Or 2.2? Would that be correct? No. This helps you know like the zone of where your answer should be. We know our answer should be in the zone of what number? 24. Okay, now let's think to ourselves. Let's actually solve it now. Okay, so we can say that 7.8 times 3 is 3 copies of 7.8, right?
Yes.
And we have to think to ourselves, what's the smallest unit in 7.8? Tenths. So let's rename 7.8 as 78 tenths. You always want to rename it as the smallest unit. Does that make sense?
Yeah.
Now, we can say that 7.8 is the same as 78 tenths, right?
Yeah.
So then 7.8 times 3 is the same as 78 what? Tenths times 3. Now can we use what we know about whole number multiplication to multiply this problem?
Yes.
We multiply the ones first. 3 times 8 is 24. So we'll record the 4 and we'll regroup the 2. Now 3 times 7 is
21.
plus the 2 we regrouped is 23. So is my answer 234?
No.
Remember, we're multiplying tenths. So our unit right now is tenths. So we need to write the unit down here. If you don't write the unit, will you get the right answer?
No.
No. So our answer is not 234. It's 234 tenths. There's 2 ways you could check this. The first way is you think back to your estimate. If I wrote that 234 was my answer, is that in the zone of 24?
No.
So right when you do that, you should think back to your estimate, and those alarms, blah, 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 should be going off in your head saying, wait a second, 234 is not in the zone of what my answer should be. That's wrong. The second thing is you have to think, did I write the same units? Do you see how this is the same as this?
Yeah.
And if I didn't write the same units, again, those alarms should go off. So I have 234 tenths. How do I write that in standard form? How would I write that in standard form, Young? Very good. Now, is 23.4 in the zone of what my answer should be?
Yes.
So I feel much better about that. So I can write my product up here. 7.8 times 3 is 23.4.